Barcodes are everywhere you look, although hardly anyone ever sees them. If you buy something from the store, it's more often than not going to have a barcode on it. Barcodes, as they originated, allow a computer interface to read an identification number which typically corresponds to further information within a database. Although some 1D barcodes, such as code 128, now contain alphanumeric characters. Here you can see some examples of common 1D barcodes. UPC-A is the standard uniform product code and is used in retail stores worldwide. UPC version E is a shrunken version of UPC-A, which has been compressed in order to fit it on the smaller items such as soda cans and cigarettes. EAN13 is used worldwide in retail companies, with the exception of the United States and Canada. All three of these are approved by the International Not-for-Profit Agency, which regulates global standards for supply chains. International standard book numbers are printed on books worldwide and identify the language-sharing country group to which it belongs, the publisher code, the item number or title of the book, and a check digit which serves for error detection. Some ISBN numbers, such as the one shown here, contain the price of the book in U.S. currency within the last 5 digits. This one, for example, cost $44.95. Code 3 of 9 is frequently used in various ID systems pertaining especially to the military or the healthcare industry, but is used in other applications as well. Code 128, unlike the fully numeric codes here, contains alphanumeric characters in both upper and lower case. PostNet is the standard sorting code for the United States Postal Service. Unlike the other barcodes shown here, it is formed by varying bars of 2 different heights. All 1D barcodes, like those here, are read by scanners which do so by measuring the amount of light which is bounced back. Essentially, it reads the white between the bars because it reflects the light, whereas the black absorbs it. 2D or matrix codes have more capacity for information storage than 1D codes. These are some of the more familiar 2D codes that have been designed, although most people are even less likely to recognize these than 1D barcodes. Whereas a scanner built for the unique purpose of scanning barcodes was originally required for the 1D codes, barcodes can now be read using mobile phones equipped with cameras and the appropriate barcode reading app. 2D barcodes are especially adept at this as they have the ability to contain a large amount of data. The current leaders in the 2D barcode field are QR code and data matrix. The QR in QR code stands for quick response, which is exactly what it was built to do. Matrix codes are especially adept at communicating with mobile devices as they can connect the user directly to a web address, dial a telephone number, cue your device to open an email with the address specified within the code, or even download an MP3. One significant area where data matrix lacks is in its inability to store Japanese text. As a result, a Japanese company created the QR code, which has become a standard in information communication and marketing practices in Japan, where every cell phone now comes standard with the programming necessary to read QR code. This is an example of a QR code. It is comprised of several basic layers to determine information about how to read the code and what data is contained within the code. Here you see 3 positioning squares, which allow the reader to orient itself. This makes the code readable no matter which end is up. Another square is for alignment. Depending on the size of the QR code, there may be one of these, none of these, or several of these. Another feature is the black and white dotted line for timing. Position, alignment, and timing are all required patterns for QR codes. Outside of these patterns, there are also specified areas for information regarding the format of the content, seen here in blue, and version information, as shown in orange. The version refers to the number of modules within the code, ranging from version 1 with 21 modules by 21 modules to version 40, which consists of 177 modules by 177 modules. The rest of the information that does not fall into one of these specific areas consists of the data and the error correction information. QR codes are built to duplicate information, allowing the message to come through even when a certain amount of code is distorted or missing. There are currently 4 levels of error correction from which the user can choose to best fit his needs. Brains and technology. Unfortunately, our brains cannot instantly decipher barcodes or 2D codes without assistance. But fortunately, our brains are capable of creating devices with which we can decipher such information more or less instantly. Some of these magical devices are portable, following the current trend, while some are less portable and less instant, although they still get the job done. These less portable versions are also quite difficult to find because of the mobile prevalence in this market. These codes often contain the mobile URLs for product being advertised, so the PC version might do you less good for those items. Gary Small on the topic of the iBrain focuses on young digital natives and how they're comfortable with multiple technologies and multitasking. He's also concerned about weakening memory. It's one more way we don't have to remember things because we can store them or Google them.